Hi everybody, here's Allsorts number 9. Same as all the other questions that we've looked at. I've read the question first, RTFQ, and then I've done my flowchart. So just to go through, it tells us that 12 grams of calcium carbonate and sodium chloride in a mixture are mixed with 100 centimetres cubed of 2 molar HCl, but only the calcium carbonate reacts. That's where my blue boxes come from. So the calcium carbonate reacts with 100 centimetres cubed of 2 molar HCl. The resulting solution is made up to 250 centimetres cubed, and then they take out 25 centimetres cubed and react it with 34.1 centimetres cubed of 0.2 molar NaOH. So thinking through what is going on with this question, okay, we've got this mixture of calcium carbonate and sodium chloride to begin with, and then it reacts with HCl, and obviously only the calcium carbonate reacts. So what we've got to think about here is what is going on in the reaction. So calcium carbonate reacting with HCl. What kind of a ratio do we have? Well, if we work out the balanced equation for that, it is 2HCl. Carbonate, remember, is 2 minus, reacting with the H plus from the acid, so we need 2 of them. So we have a ratio there. Then it's made up to 250, and then we've got a reaction going on between sodium hydroxide that's added and whatever's in the solution. So what's in the solution at the end? Well, this sodium hydroxide at the end is actually going to be reacting, the only thing it can react with is hydrochloric acid. So there will be leftover hydrochloric acid, which we can call an excess HCl, and that's what's reacting. So this is our common ratio that I've mentioned before, NaOH to HCl, which is always a 1:1 ratio. Now they're asking us to calculate the percent by mass of calcium carbonate in the mixture. So what we're aiming to find with our mole calculation is the mass of calcium carbonate. That's what we're aiming for. So again, this is a true back titration. Okay, we'll be using 2 chemicals to react to begin with, using an excess of 1, and they're doing a secondary reaction to work out, going backwards, how much we had originally. So we are going to do that working backwards through our flowchart, and I'm going to start with the red box and look at the information that we've got. 25 centimetres cubed reacts with 31.4 centimetres cubed of 0.2 molar NaOH. So that's the first thing we can do. Because we have a concentration and a volume, we can work out moles of NaOH. And if you're ever stuck, always look for that. So concentration is 0.2 and the volume is 34.1, but we have to divide that by 1,000 to get it into decimetres cubed. Now if you put that into your calculator, it comes out to be 6.82 times 10 to the minus 3 moles. Now looking at the working that we did at the beginning, what is that sodium hydroxide reacting with? It's reacting with the HCl. So because we have NaOH to HCl being 1:1, we can say that the moles of HCl in 250 centimetres cubed is also 6.82 times 10 to the minus 3. So that's the red box. We can't get anything more out of that. We've considered the volume and the concentration of sodium hydroxide. We've considered the volume of the HCl, and now we've got to move on a box. So back to my green. The green box is saying that we've got 250 centimetres cubed of solution. Now we took out 25, so what can we do with that? Well, 250 centimetres cubed of the original solution divided by how much we took out will tell us how many portions we had. And so what we've got is a times 10 factor of how many moles there will be between what we've just worked out, 6.82 times 10 to the minus 3 in the red, and then what will be in the green 250 centimetres cubed solution. So moles of excess HCl in the 250 centimetres cubed is 6.82 times 10 to the minus 3 times by 10, which is 6.82 times 10 to the minus 2 moles. And so that's how much HCl was left in the reaction afterwards. And that is after reaction with calcium carbonate. So that's everything in the green box. So what can we do now? Let's move on to what the blue box tells us. So we did have a reaction, calcium carbonate reacting with 100 centimetres cubed of HCl. Well, we can work out how much HCl there was originally. So original moles of HCl, again, is conc times volume. Concentration this time is 2, and the volume is 100 divided by 1,000. So that comes out to be 0.2 moles. And that's how much acid we had at the start. We can then work out the moles of HCl that actually reacted. And that is going to be the original moles minus the excess moles. I was going to make that green, but never mind. So 0.2 minus the 6.82 times 10 to the minus 2 moles that we worked out before, and that comes out to be 0.1318 moles. And that is how much actually reacted with the calcium carbonate at the start. So looking back at our flowchart, we've worked out how much calcium carbonate, how much acid reacted with the calcium carbonate. Now we can use this ratio to work out how much calcium carbonate there was. So calcium carbonate to HCl, we said was a 1:2 ratio. We haven't got 2 moles, we've got 0.1318 moles of HCl that reacted. So what we're going to do is divide by 2. And so 0.0659 moles of calcium carbonate reacted in the first place. That's how much calcium carbonate there was in that mixture of solids at the start. So, just to double check where we've got up to, okay, we have worked our way back through the red box, the green box, we've used the blue box, we've talked about the ratio. So the last thing to do is to think about this percentage by mass. We want to find mass of calcium carbonate. Well, now we have the moles of calcium carbonate. So mass of calcium carbonate is going to be moles times mR. Calcium carbonate is 40 plus 12 plus 3 lots of 16, which is 100, possibly 100.1, but at this point just want to make sure the working is sorted. So 0.0659 for the moles times 100 as the mR gives us a mass of calcium carbonate of 6.59 grams. The question asks for the percentage by mass. So that is the mass of calcium carbonate over total mass, all times by 100. So 6.59 divided by 12 times 100, and if you put that into the calculator, 54.9%. The mark scheme I think says 55.0, but within the rounds, the worlds of rounding and the MR perhaps not having the right decimal places, that will absolutely do. As always, if you've got any questions, just let me know.